Assalamu alaikum. In the previous video, we learned about projectile in horizontal projection. In this video, we'll discuss about a projectile under an angular projection. So for that, I consider an object which we call as projectile thrown from certain point. For example, I take this point from where the projectile is projected with some initial velocity in air. When it is done so, it starts moving in this particular direction. This is the path followed by the projectile, and we called the path followed by the projectile as trajectory. So this is the trajectory of the projectile under angular projection. Why it is called as angular projection? Let me tell you. This is a trajectory. Trajectory is nothing but the path followed by the projectile under projection. Now, the line that I draw here is nothing but the horizontal or the ground. Okay. And as I told you earlier, here the object is thrown with some initial velocity. Here, the tangent drawn to this parabolic path uses the direction with which the object is thrown. It represents the initial velocity u vector. Okay, and here, as said, I will tell you why this projection is called as angular projection. There is another name of angular projection is oblique projection. Oblique projection. When an object is thrown with some angle to the horizontal, then it is referred as angular projection or oblique projection. An object in angular projection always follow a path which is nothing but parabolic in nature. Now here, see, if you look at this diagram carefully, you may find that the path followed by the projectile is nothing but an inverted parabola. This is an inverted parabola. Here, for my convenience, I take this point from where the object is thrown as A, and this point where the object or the projectile reaches the maximum height as O. This is taken as O, and the point where it hits the ground is taken as B. So during motion, the object from point A reaches the ground through point O, where it attains maximum height. Okay. Now before going ahead, let me provide some more information about this one. And as I told you, we have projected the projectile with some initial velocity which is represented letter u vector. Clear? Now, as the object travel or shows its motion both along x-axis as well along y-axis. How could I say that the object shows the motion along x-axis? You can see the object was present at A earlier. After some time, it has reached point B, which is located along the x-axis. In a similar way, there is a point at O that shows that it is at certain height from the ground. Okay, let me name this one. I take this height as the maximum height, represented h max. Clear? So the projectile shows its projection along the y-axis as well. So it has got two components, one along horizontal direction, another along here. Velocity vector has got two components, one along the horizontal direction, another along the vertical direction. Okay, now I'm going to find out the horizontal and the vertical component of this initial velocity u. Okay, I name this horizontal component as ux. X for the reason that it is acting along the x-axis. Okay, and here the vertical component is named as uy, as it acts along the y-axis. Okay, uy. Clear? Now, what are the values of these two things? To get the value of horizontal and the vertical component of u, I extend a line. I drop a perpendicular from the tip of u. Okay, in the downward direction, it intersects on there's a horizontal line. Okay, or on this ux. Clear? And next, I'll do the same thing with this as well. Okay, I drop a line from its tip such that it can intersect on uy. Understand? Now you can see, you may find a rectangle here. Okay, which comprises of two right angled triangle. I take this right angled triangle in which the angle is theta. Clear? The side which is present here opposite to this one is called as opposite side. Okay. Okay, for better visibility, I will draw this part alone here. Okay, this is the vertical component, and this one is the horizontal component of u. This is u. Fine. Here I have dropped a line. The same thing I do with this as well. Okay, now it forms a rectangle. Here angle between u and ux is theta ux. This is the uy. What is this? This is uy. Okay, now I'm going to find out the values of these two things. As I told you earlier, this side is called as opposite side of this right angle triangle. Notice so this is the hypotenuse of this right angled triangle, and this one is the adjacent side. What is this? This is the adjacent side of this right angled triangle. Now I do want to know the value of ux and uy. So if I know what is adjacent side and opposite side, then their value can be obtained easily. Okay, so let's do it. I'll start with this equation, sin theta. What is sin theta? Sin theta is nothing but opposite side divided by hypotenuse. Okay, what is the value of opposite side? That is unknown to us. Okay, and according to this diagram, opposite side is uy. that I mentioned here, uy. Okay, why is it so? This line is just parallel to this. So whatever value that it have is going to be equal to uy. So it is written in this manner. Then next, hypotenuse. What is hypotenuse here in this diagram? Hypotenuse value is u. That I write. Okay. Now, if I cross multiply this one, I'll get the value of uy. Let's do it. Here uy is found to be equal to u sine theta. Okay, we got the value of uy that I am going to mention here. Now before that, I'll box it. Okay, now I'll go ahead. I'll write value of cos theta. What is cos theta? Adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. Cos theta value can be obtained with the help of this formula. Okay, this you might have studied in trigonometry. Now adjacent side here is provided with value ux. According to this diagram, ux. Adjacent side, and hypotenuse is u. Is u. Okay. Now I'll do the same thing. I cross multiply this to get the value of ux as you did with the uy. Okay. And now ux is kept as such. Then this u is taken to the other side. So it will multiply u cos theta. Fine. Now for better visibility, I'll box it. We got the value of ux and uy, which are nothing but horizontal and vertical component of velocity u. Clear? Then I am going to write here where the side is uy equals to u sine theta, and here ux equals to u cos theta. Okay, so throughout this topic, wherever you come across ux or uy, there you need to write their value as we have obtained here. Okay, let's do it. Now before going ahead, let me provide some more information about this diagram. Okay, now here when we throw the object with some angle to the horizontal, it starts moving upward. Now when an object moves upward, it means it is going against the gravitational pull of the earth. Okay, it is traveling against the gravitational force. Okay, so as a result, what happened here? Gravitational force of the earth is constantly pulling the object which is under motion. So due to the initial velocity, it has reached point O. At point O, the velocity, that is Vy, becomes equals to 0. Now the object comes to rest here. Afterwards, again, the gravitational pull is acting on it continuously. So it starts pulling it downward. So it moves, it traces this path before reaching point B. Clear? That is why the trajectory is the inverted parabola here. Got it? So when the particle or the projectile reaches maximum height, here the final velocity at that point is found to be 0. Okay, and after that starts traveling with velocity, and that velocity keep increasing due to gravitational pull of the earth. Okay, Now we'll go ahead. First, I'm going to discuss about the velocity of the object or the velocity of the projectile. See, whenever I use the term object here, it represents a projectile. That projectile may be anything. It may be anything. Now we throw a ball standing on a ground with some initial velocity by making an angle theta to the ground. Then it comes under angular projection. The next cannonball, shot from a cannon in a battlefield, is an example of angular projection. Water ejected out of a hose held at one particular angle can be referred as angular projection. Okay, so in this way, what will be the velocity? Velocity of a projectile at a given time t along the horizontal direction, or you can call it as velocity in the horizontal motion. Okay, let me get the expression for velocity here. Okay, for that I use the kinematic equations of motion. What are they? The first kinematic equation of motion is nothing but v equals to u plus at. Second one is s is equal to ut plus half at square, and third equation is nothing but v square is equal to u square plus 2as. Now I'm going to use these three equations here. I'll start with the first equation of motion. First equation of motion. Which is nothing but v equals to u plus at. Okay. Now, here the object is moving along a horizontal direction. So, it means that the object is moving along the x-axis. So, I am going to make certain changes to this equation. Here, v is replaced with vx, and u is replaced with the ux, and a is replaced with the ax, and t is kept as such. This is that I am going to find out the velocity of the object at a time t. Okay. Now afterwards, to save the space, I write the values of these things beside it. What are they? See here. Ux. What is the value of ux? Now we got the expression for ux. It's nothing but u cos theta that I am going to use here. Ux is u cos theta, and here, see, listen to this carefully. This component of velocity remains the same throughout the motion of the object. Okay. Suppose I take a point here. This is the horizontal component of a velocity at this point, and is found to be u cos theta. Clear? The next, the vertical component at this point is u sin theta, and it is found to be acting upward. Then here, at this point, like I'll take one more point here. At this particular point, the horizontal component is acting in this direction, just the same direction. But the vertical component acts in the downward direction because the orbit has started moving downward, whereas here the orbit is moving upward when it travels from A to O. Clear? So the vertical component of a velocity is acting upward at this particular point. And one more thing, here as the object move from A to O, its velocity, or we can say its the vertical component of a velocity is keep reducing and becomes zero at point O. The similar way, when it starts moving from O to B, the vertical component of velocity is keep increasing, okay, and reaches the maximum value at point B. Okay, but throughout the motion, this horizontal component of velocity, that is u cos theta, remains same. So it is a constant. It is a constant. So as this is a constant, there is no acceleration along the horizontal direction. So ax is taken as a 0 here because there is no acceleration. When there is no change in the velocity, it means the orbit is not accelerating. Hence the acceleration is 0. Now I am going to substitute the value of ux and ax in this equation. Okay. And one more, let's do it. After substitute all these things, Vx is found to be equal to u cos theta, here 0 multiplied with the t gives us 0. Okay, so the value that we obtain here is nothing but Vx is equal to u cos theta. This is the velocity of the projectile at time t along the horizontal direction. Okay, I box it. Fine, then I'll move ahead. Now I'm going to find out the distance covered by the object along the horizontal direction. Distance covered by the projectile in a horizontal motion. Horizontal motion. What is that? Yeah, the distance covered can be obtained with the help of a second equation of motion, and that's nothing but second equation of motion. Second equation of motion. What is that? It's nothing but this. S equals to ut plus half at square. This is the second equation of motion. Now, I'm going to modify this equation according to our case. So, in the place of S, I write S x because the object is moving along the x axis. Then U is written as ux and t is kept as it. This is the time. The half, the place of a, I write ax, then t square. Now, before I go ahead, I am going to mention the value of sx, ux and ax as we did earlier. Okay, but we know the value of ux. No, it's written here. Here sx is taken as x. Okay, this is the distance covered by the projectile along horizontal direction. And ux is nothing but u cos theta, and ax. There is no acceleration along the horizontal direction, so it is 0. I'm going to substitute all these things in this equation. Substituting Sx, Ux and Ax values. And in the previous equation. So what I'll get if you do so? See what I get? I get this. In the place of Sx, I write its value. There is nothing but x. In the place of Sx, I written its value. That is x. In the place of Ux, I write u cos theta. Then t is kept as such. And here half. In the place of ax, I write 0. So this whole term will become 0. We need not to mention that one in the next step. Okay. So this equation becomes x equals to u cos theta t. This is the distance covered by the projectile in time t along a horizontal direction. Okay. Now here, before I go to the next thing, I'm going to find out the value of t from this. It can be obtained easily just by cross multiplication. Okay, I'm going to keep a t here as such, and the remaining term is taken to the other side. Here t is kept as such, and the remaining term is taken to the other side. Here it multiply, when it is taken to the other side, it will divide. Okay, so x are divided by u cos theta. This is the expression for time. I'm going to use this one. I'll take this one as equation number 1. Right? So the next case I'm going to use it. So it is named as equation number 1. So but this one can easily find out the velocity and the distance covered in the horizontal motion. Now we will get the velocity, the expression for velocity of projectile at the time t in a vertical motion. Here we got the expression for v for horizontal motion. Here I am going to get the expression for v in a vertical motion. Understand? Let's do it. Now for this I start with the first equation of motion, as we did here in this case. What is this first equation of motion? First equation of motion is v equals to u plus at. Now for our case, as the object is moving up, here we talk about the vertical motion. So all these terms are replaced with the new terms according to our case. So v is replaced with vy, and u is replaced with uy, and a is replaced with ay. And here time should not be changed. It is an independent variable. So it is kept as such. Okay. Now, what are the values of these things? Let me mention here. Here uy. What is uy? Uy is u sin theta. U sin theta. and here the object is either decelerating or accelerating. Here, from when they will move from A to O, the velocity of the object decreases. When it moves from O to B, the velocity of the object is increasing, isn't it? That means it accelerates. So that acceleration here is due to gravity. So it's taken as a G. But if you look at the diagram carefully, you may find that here we have thrown the object and it starts moving upward, against the gravitational pull. So J is taken to be equal to minus G, because this acceleration is just opposite to acceleration due to gravity. Fine. So these values I am going to mention in this equation. So what I'll get if I do so? I'll get this Vy is going to be equal to u sin theta here plus minus of G multiplied with the T. If you multiply minus sign with the plus, you'll get minus. Not write in the next step. See, Vy equals to u sin theta minus a G T. This is the equation which gives the velocity of the projectile at time t in a vertical motion. Okay. I box it for better visibility. Now I'll go ahead. I'm going to get the expression for distance covered in a vertical motion. Distance covered. Covered in vertical motion. Distance covered in the vertical motion. Okay, how to get that? Here, distance covered can be easily obtained with the help of the second equation of motion. Okay, second equation of motion. Yes, S equals to ut plus half at square. Now I'll modify this according to our need. Okay, how do I do that? Look at it carefully. Here S is taken as y, and u is taken as uy. T is kept as such, plus a is taken as ay and t square. Fine. Next, I'm going to write the values of these things. Here sy is taken as y, no, distance covered by the object in time t along vertical direction. So it's y. Then uy, we know the value of uy. What is that? U sin theta. And ay is taken as minus g, as we did in the previous case. Okay. Now I'm going to substitute this value here. See what I'll get. In the place of yes, I write its value, that is y. Y is equal to, in the place of u, y, I write u sin theta. U sin theta multiplied with the t, kept as such, plus half minus of a g t square. Understand? Now, see what I'll do now. That it's value in the next step. Y is equal to u sin theta multiplied with t, then plus multiplied with minus is minus g t square. Now we know the value of t. Now that is mentioned in equation number 1. So from equation number 1, I am going to substitute the value of t in this equation. Okay. So before doing so, I am going to box this. Okay. And I take this one as equation number 2. Let's take as equation number 2. Now I'll substituting equation 1 in 2. What I'll get if I do so? Let's find out. Here, y value u sin theta. In the place of t, I write this x upon u cos theta minus half g. Then I square this value. Then I substitute here that x square upon. Now I skip one step here. When I square the whole term, what is present in the numerator will become x square, u will become u square, cos theta will become cos square theta. Fine. This is what I get. Now I'll simplify this. Here u and this u get cancelled. Here, okay. Everything remains same here. Now, what I get? Y is going to be equal to. Here we have x, then sin theta divided by cos theta. We know sin theta divided by cos theta is tan theta. That I will write in the next step. Half, then g x square upon u square cos square theta. Okay. Now I'm going to write this after certain changes. Here sin theta upon cos theta is a tan theta. So x tan theta. This you might have studied in trigonometry. Half g upon u square cos square theta. What is left here is x square. I take this within bracket and I take x square outside. Okay, this is the final expression that we obtain. And here, this equation is the equation of inverted parabola. So this clearly shows that the path followed by the projectile is nothing but an inverted parabola. Okay, and here before I go to the next step, one thing I do want to tell you here is here sin theta divided by cos theta is nothing but tan theta. Okay, should not get confused. Okay, now I'll box it before I proceed. This is the equation we obtained. It represents that the projectile moves in parabolic path. Clear? So the path followed by the projectile is an inverted parabola. This is what we understand from this equation. Now we'll get the expression for maximum height reached by the projectile during its motion. Here I represent the maximum height by letter H max. It is shown in the diagram, no? Using a blue line. Okay. Here the maximum height is nothing but the highest vertical distance covered by the projectile during its motion. Okay. So in our case, the projectile is projected from point A. Before it hits the ground at point B, it reaches a point O, which is at a maximum height from the ground. Okay, so at point O, the projectile is at a maximum height. Now, to get the expression, I use a third equation of motion. Third equation of motion, which is nothing but v square equals to u square 2a. Yes, fine. Now I am going to modify this equation according to our case. Now here, when we talk about the maximum height, we have to consider only the vertical motion of the object. So, the motion of the object along the y-axis is considered here. So, v is taken as vy and u is taken as uy plus 2 is written as such, and a is taken as ay and s is taken as sy. Oh, and it represents the maximum height here. Now I am going to mention the value of these parameters one by one. Here vy is taken as 0. Why is it so? Now already I have mentioned, when the object is projected from A, it traces this path. At the beginning, to reach O from A, it starts moving upward, okay, which is against the gravitational pull of the earth. Here, earth is constantly pulling the projectile in the downward direction. So, the velocity of the projectile decreases constantly. So, when it reaches the maximum height at this point, its final velocity is found to be 0. Clear? The next uy. Now uy is taken as u sin theta, and here ay, which represents acceleration along the y-axis, is taken as a minus g. Then next sy, here sy, distance covered along the y-axis is taken as a maximum height, h max. Okay, I am going to substitute all these things in this equation. What I'll get if I do so? The place of vy, I write 0. Even if you square it, you are going to get a 0. Uy, u sin theta whole square plus 2. The place of ay, I write minus g. The place of sy, I write H max. Okay. The next square of 0 becomes 0. Yet if I expand it, u will become u square. Then look at carefully how I square sin theta. After squaring sin theta, we write it as sin square theta. This you might have studied in lower class. And here plus multiplied with minus is a minus 2g h max. Here aim of mine to get the expression for h max. So I keep this term one side. Actually, it is taken to the another side. When I do so, minus n will become plus. Minus 2g become plus 2g h max. This is found to be equal to u square sin square theta. Okay, this is what we get. Now, I will keep h max at one side and the remaining term is taken to the another side. H max is kept here and what remains is 2g is taken to the other side. So it will divide u square sin square theta divided by 2g. This is what I get. I'll box it. I'll box it. Okay. So this is the expression to get the maximum height. Now we'll get the expression for time of flight. Time of flight, which is represented by letter capital T F. What is this time of flight? Time of flight is nothing but the time taken by the projectile to reach the ground from the point of projection. Okay, so in our case, how much time the projectile will take to reach B from A is referred as the time of flight. Here, to get the expression for TF, I start with the second equation of motion. I use the second equation of motion. For motion is that second equation of motion is nothing but S is equal to ut plus half at square. Okay. Now before I proceed, before I go ahead, I am going to make certain changes to this equation according to the need. Yes is taken as yes x, not x, sorry, yes is taken as yes y and u is taken as uy, and here t is the total time, so it is replaced with the tf. Same way, half v is written as a, y is written as t f whole square. Okay. Now, what is the value of s y? Here, s y is taken as y, which is found to be equal to 0. Okay. So displacement along the y-axis is found to be 0. Why is it so? Let me tell you. Here, actually, when you move from A to O, the distance covered, the displacement covered is h max. The similar way, when you move from O to B, the displacement covered is h max, but in the opposite direction. So, here the displacement covered from A to O is h max. Then the displacement covered from O to B is also h max, but in the opposite direction. Like this, plus minus. So what do you get? 0. This is the value of Sy. Got it? Next we have Uy. Uy is nothing but U sin theta. U sin theta. And here Ay is taken as minus G. Okay. Now I am going to substitute all these things here in the above equation. See what I get? First, the value of Sy is nothing but 0. And Ay is U sin theta. And Tf is kept as such. And here plus half minus G. Tf square. Okay. Now, when I expand this, I get this sin theta Tf minus half G Tf square. Now, in the next step, I am going to take this term to the other side. Here, minus sign will become plus when it is taken to the other side. So, half G Tf whole square equals to U sin theta Tf. Understand? And here the similar terms get cancelled. And what remains is this half G Tf equals to U sin theta. Here my aim is to get the value of Tf. So Tf is kept as such and the remaining terms are taken to the other side. Is kept as such, remaining terms are taken to the other side. So what will happen? Here we have U sin theta. 2 is in denominator. When it is taken to the other side, it will go to numerator to multiply. And a G which is in numerator on taking it to the other side will go to denominator. This is the final expression which provides us time of flight. Right? Now we will get the expression for range. Range. Which is represented letter R, which is otherwise known as horizontal range. What is this? Horizontal range or just range is nothing but the distance between A and B in our diagram, and it is defined as the horizontal distance covered by the projectile from the point of projection to the point where it hits the ground during its motion. Okay, so what is a range and how we get its expression? To get the expression of R, I start with the second equation of motion. Second equation of motion. Nothing but S equals to T plus half it is square. Okay. Now in this case, now I am going to modify this equation according to our need. Okay, according to the case. Here I take the distance along the horizontal direction. So let me represent here. This distance along the horizontal direction between A and B represents R. Represents R. Okay. So we have to take only horizontal motion here. So S is taken as Sx and U is taken as U x, and here T is taken as TF, total time, isn't it? And A is taken as AX TF whole square. Yeah. Now here the value of Sx is nothing but R. The displacement covered along the horizontal direction is R, and Ux is taken as U cos theta. Then here we know this velocity along horizontal direction remains the same, so there is no acceleration along x-axis. That is taken as a 0. And we know the value of a TF. I'll mention here. The TF is 2u sin theta upon the g. All this value I am going to mention in the above equation. So what I will get if I do so? I will get this. In the place of Sx I write R equals to, in the place of Ux I write U cos theta. Then in the place of TF I write its value. What is that? 2u sin theta upon g. Then plus half. In the place of Ax, its value is 0. So the value of TF is 2u sin theta on g whole square. Okay. Now here, when this term is multiplied with 0, it is going to become, it will vanish, it will disappear. Okay, then 0. So in the next step, the value of R is going to be equal to, see, U, already U is present here. These two things multiply with each other. So U square 2 sin theta cos theta divided by G. Okay. Here I skipped one step. Oh, I arranged it. Instead of writing U square cos theta 2 sin theta upon G, I have just rearranged it. The next, look at this carefully, what I do. Hey, you may know this equation. 2 sin theta cos theta. This one to be equal to sin 2 theta. Think you know this? So that I am going to use here. This is the equation. Fine. So R written as U square sin U square sin 2 theta divided by G. This is the final expression which gives us the range. Okay. Now I'll box it. Fine. This is the final expression I obtain. Okay, which provides us the range. Now, if you look at this equation carefully, you will find that here the range depends on the initial velocity with which the object is thrown, and also it depends on the angle, sine of the angle theta. Okay, here angle is represented by theta, and it inversely depends on the acceleration due to gravity. It is quite clear from this expression. So when I say that, it depends on the angle. To have the maximum range, suppose I throw some object and I want that object to reach a maximum range. To attain the maximum range, what has to be done? See? For that case, if we have our max to be equal to u square upon g. So this is the condition for the maximum range. When you will get it, so I just compare these two. So here, if I have nothing, means it means the value is 1 here. If you compare these two, you will get the value. No, I write this one here. So on comparison, what I get? If you compare sine 2 theta, this two equation, if you compare, you get sine 2 theta equals to 1. When the value of sine 2 theta will be equal to 1, we know sine of 90 equals to 1. It means I'm comparing these two equation, two theta is found to be 90 degree. If it is so, then theta is equal to 45 degree, isn't it? 2 theta is equal to 90 degree, then theta will be equal to 45 degree. This clearly shows that when an object is thrown by keeping the angle equal to 45 degree, it travels a long distance along the horizontal. Okay, this is what it means. That is why if you see cannons used in battlefield are kept, they have the pipe through which the cannon is projected at an angle of 90 degree. Even tankers have the tube kept at an angle of 45 degree. By doing so, what happened? Water is shot from there, travels a long distance. And even if you see the athletes who throws the shot put or javelin, holds the shot put or javelin in such a way that it makes an angle of 45 degree with the horizon, with the horizontal direction. Okay, so to attain the maximum range, one has to throw the projectile at an angle of 45 degree. This is what we understand from this expression. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.